Part 3, horizontal asymptotes. Again, this one will probably be a little longer than the last one, but not nearly as long as the one before. So we're kind of in the middle. So, horizontal asymptotes, we saw these first in Math 30-1. Okay, we're now going to discuss these in terms of limits. This also builds on our discussion of infinite sequences. So that's Unit 2, subsection 7, and we're going to use some of the same skills here as we did there. So if you need to go back and review, but watch the video first because I'm sure it'll come back to you. It's reasonable. So, the following points emphasize some of the important limits that earlier sections dealt with. Okay. Now, if n is a positive rational number, so a positive number, rational is just a fraction, but as long as it's positive, okay, so then 1 over x to the n, okay, so as long as x is positive, or n is positive, this is going to equal 0. Okay, 1 over some really big number, 1 divided by a big number is a small number or 0. Okay, so that's how that one works. If n is a positive rational number and x to the n is defined for all values of x, okay, all this means x approaches negative infinity. So remember, negative infinity, that makes x to the n a negative, or x is a negative number. So negative numbers to the n, okay, so that's just really big. Again, 1 divided by really big is 0. Okay, so those are two limits that are really going to help us. Okay, we can use the above limits to find a horizontal asymptote, and here's how. Okay, so a horizontal asymptote for a graph will exist only if x approaches plus or minus negative infinity of f of x exists. The equation for the horizontal asymptote then will always be y equals that whatever that limit is. Okay, now you probably listen to that and like words, blah, blah. Okay, well, let's show you how this is supposed to work. All right, use your prior knowledge of limits to find. Okay, remember in that sequences and series, so that was sequences lesson, what did I say, lesson 7, okay, in Unit 2. Okay, when we have limits like this and it approaches infinity, remember we're supposed to divide by the highest power of x. Remember that thing? So we divided by x squared, divided by x squared, divided by x squared, divided by x squared. So 3x squared divided by x squared is just, so limit as x approaches infinity. Okay, 3x squared divided by x squared was just 3. Then 4x divided by x squared. Oh, well, look, the x's can cancel, so that's going to be minus 4 over x. Okay, then x squared over x squared is 1, and 5 over x squared, so plus 5 over x squared. Now, remember, as x approaches infinity, 4 divided by infinity, that's pretty close to 0. So that's 0, and then this guy is really 0 because it's infinity squared. Okay, but oh, the squareds canceled off the 3 and the 1, so this just equals 3 over 1, which is just 3. So that limit, okay, so that limit is going to be our horizontal asymptote now. So that's cool. Nice. So we do the same thing here. As we approach negative infinity, so we divide by x, divide by x, divide by x, divide by x. Remember, we are always dividing by the highest exponent of x, anywhere in the equation. Okay, awesome. So this is just the limit as x approaches negative infinity. Okay, so that's going to be 2 minus 1 over x, and then 1 minus 3 over x. Okay, and then when we approach negative infinity, that's going to be a 0, that's going to be a 0, and this is 2 over 1, or just 2. Now, the significance of the negative infinity here is we're going to be approaching 2 kind of from the underside of it. You know, we're going to talk about that later, so let's not get bogged down. Okay, so the limit here is just 2, so our horizontal asymptote is going to be 2. Okay, when we have 3 to the x, so when x is infinity, so we get 3 to the infinity, which is just infinity. So that doesn't look like it's all that important right now because it's infinity. Okay, it's definitely not a horizontal asymptote. So I should connect those. Okay, so 3 to the infinity is infinity. But if you look at D, okay, as x approaches negative infinity for this, so 3 to the negative infinity. Well, remember, guys, that negative exponent is just 1 over 3 to the positive infinity. Well, 3 to the positive infinity is pretty big. It's infinity. So 1 divided by infinity is 0. Oh, do you guys remember what 3 to the x looks like? It's one of those exponential ones. It kind of looks like that. So even though there's no horizontal asymptote on the positive side, right? There's no asymptote over here, but the x-axis is a horizontal asymptote because the negative part gets closer and closer to it but never touches. So anyways, that's why 0 is a horizontal asymptote for this function. All right, examples. Determine the horizontal asymptote for this function. Okay, so remember we're going to write the limit as x approaches infinity of 3x minus 2. I'm going to leave a little bit of space, x minus 1. Because remember, we're going to divide by the biggest power of x, which is just x to the 1. So this works out to the limit as x approaches infinity of 3 minus 2 over x. Okay, 1 minus 1 over x. Okay, so those parts equal 0, those parts equal 0. Okay, and we end up with 3 over 1, or just 3. So that is the horizontal asymptote, or that's the limit. So the equation of the asymptote is just y equals 3. Okay, I guess we could say horizontal asymptote at y equals 3. Terrible at sign, but you get the idea. Okay, B, determine the vertical asymptote of this function. So remember, the vertical asymptote is when the bottom equals 0. So the vertical asymptote is at x equals 1. Okay, that's when the bottom equals 0. So we have a vertical asymptote at x equals 1, so along this line. We have a horizontal asymptote at y equals 3, so that's this line. And now we have to sketch the function. So, where does it swoop and stuff like that? Okay, so again, we could do a quick little limit thing here. So we go the limit as x approaches 1 from the left. So as we approach from this side, okay, so those are going to be like 1.1, sorry, pardon me, that's going to be like 0.9s, 0.99. So 0.99 minus 1 is a negative small. So 1 divided by negative small is negative infinity. So we have the negative infinity like this, and then it comes up and then swoops towards the asymptote, and the other one then, okay, so negative 1, so that was 3x minus 2 over x minus 1. Okay, that was negative infinity. So, of course, the limit as x approaches 1 from the right, that is going to be positive infinity. Okay, so positive infinity, and then, of course, it just swoops like that. Okay, great. So that's a very rough sketch, but it works. Okay, and then 2, find the horizontal and vertical asymptotes of this guy here. So, okay, so the horizontal or vertical asymptotes, this function it's never undefined. You're not dividing by 0 or square rooting a negative or anything like that. So there are no vertical asymptotes. For this function. For that graph. Okay, so no vertical asymptotes, awesome. Now what about the horizontal asymptotes? So the horizontal asymptotes, okay, so that is the limit as x approaches infinity. Okay, well that's going to be 2 to the x minus 4. So that's going to be 2 to the infinity minus 4, which is infinity minus 4, which is just infinity. So that really doesn't help. Okay, well, let's try the other one. What as x approaches negative infinity then? So of 2 to the x minus 4. So that's 2 to the negative infinity minus 4. Well, remember, that's just 1 over 2 to the positive infinity minus 4. Well, 2 to the positive infinity is infinity. 1 divided by, or really, really big, 1 divided by big is 0. So this guy is 0. So my horizontal asymptote, or my limit, again, is negative 4. So my horizontal asymptote is at y equals negative 4. So there was no vertical asymptote, and the horizontal asymptote was at y equals 4. Okay, a few more of these, and then we're done. Okay, so find the vertical and horizontal asymptotes of these. So we have a vertical asymptote at x equals minus 1. Okay, hopefully you find that's really straightforward. Okay, now the horizontal asymptote. So the limit as x approaches infinity of x minus 3 over x plus 1. So remember, we divide everything by the biggest exponent on the x, so just x to the 1. So this is the limit as x approaches infinity, okay, of 1 minus 3 over x, 1 minus 1 over x, and as x approaches infinity, those guys equal 0, so it's 1 over 1. So the horizontal asymptote happens at y equals 1. Okay, great. Easy, easy. Now, I know what you're thinking or what your questions are. Do we have to do the limit thing every single time? Yes. Yes, you do. Okay. Again, in just quickly figuring it out, yeah, divide by x, divide by x, divide by x. Okay, that works, but that's not showing your work. So please don't just do that. Again, you can use that to check your answers, but I still want you to figure out the limits. Okay, so this guy we have to factor to find our vertical asymptotes. So we get x. Okay, so that's going to be 3 and 2 minus and plus. So x plus 2. Wow, that's terrible. X plus 2. Okay, so we have vertical asymptotes at, okay, so 3, and, well, see, that's just getting lazy. Sorry. Okay, so at x equals 3 and x equals negative 2. So those are our vertical asymptotes. Okay, no big deal. And then we do the limit thing. So the limit as x approaches infinity of x over x squared minus x minus 6. Remember, divide by the biggest power of x all the time. Whoops, pardon me, that's the biggest power is x squared. Haha, funny. Okay, so 1 over x squared, so that's just going to be 1 limit as x approaches infinity of 1 over x over 1 minus, okay, that's going to be 1 over x. That's minus 6 over x squared. So, oh boy, so this guy here is 0. This guy is 0. This guy is 0. So this works out to 0 over 1, which is just 0. So our horizontal asymptote happens when y equals 0. Okay, and then our last one. So find the vertical and horizontal asymptotes for these guys. Okay, so how this works is we need to factor the top, we need to factor the bottom. Okay, so let's get started on that. So we have 4, 1, oops, help if I wrote a 1. Okay, so 4, 1, 2, and 2, and then 2 and 2. So factors of 2 that add to negative 1. Okay, so does that one work at all? So, okay, so note the top is not factorable. Okay, that's fine. But we still had to check it. So 4x squared minus x plus 2. Okay, and then the bottom, okay, so 6, 1, 3, 2, 1, and 1. And we need them to add to 5, so that's those guys. So 3, 2, 5, plus, 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 plus. Okay, so we end up with a 3x and a 2x. Remember, you do this whatever method you want. So the 3x multiplies the positive 1, and the 2x multiplies another positive 1. Okay, so x cannot equal negative 1/3 or negative 1/2. So that's our vertical asymptotes. So our v vertical asymptotes at x equals negative 1/3 and x equals negative 1/2. So those are our two vertical asymptotes for this guy. Now the horizontal asymptotes, so that's the limit as x approaches infinity, okay, of 4x squared minus x plus 2 over 6x squared plus 5x plus 1. Okay, and the biggest power of x is x squared, so we divide everything by x squared. You know what, guys? I can let you shortcut it from here, because from here you guys can tell that it's going to be 4 over 6. Now, of course, you can't leave it as 4 over 6. So is that a good compromise, making that shortcut? You still have to write the limit. Okay, anyways, that's 2/3. So the horizontal asymptote is at y equals 2/3. All right. Well, that is it for part 3. A little longer than the last one, but again, not nearly as long as that first one. So sorry about that again. Talk to you later. Call me if you need. Bye.